Okay, let's start the session. So last time we were seeing how to replicate data from ECC to HANA. So today we'll start with the requirement, and based on the requirement we'll see how to build a solution in HANA.
Mr. Nagar, can you hear me?
Yeah, I can hear you.
Yeah, there are lots of distraction behind you. Look like the fan is on or something.
Oh, okay.
I can hear a lot of distraction.
Okay, don't worry. I'll off the fan.
Yeah, now we can proceed. I think it's there is some problem. It's now we're not able to record.
Zubair, are you fine now? Zubair?
I'm perfectly fine, sir. Thank you very much.
Okay.
Yes, sir, I can hear you.
Okay. So today we'll start with data modeling. So first let us start with what is data. Data is basically of three types. One is structured, semi-structured, and unstructured data. Now when we say structured data, data is stored in the form of tables. It's in rows and columns. Again, in structured data, I'm just explaining the term data. Especially when we want to store business data. There are two kinds of data. One is master data. The other one is the transaction data. Master data is further subclassified into three attributes: text and hierarchy. Attributes, text, hierarchy. I'll try to explain. Please give 1 minute. In transaction data, most of the time is amount or quantity related data. So first of all, structured data is stored in the form of tables. Master data. Under master data you have attributes. Now what is master data? Master data is a data that does not change so frequently. For example, let us take an example over here. Customer. I'm just trying to give you some basic foundation. Sagar, are you there in the class? Hello, Sagar? Sagar, are you there? Hello? Hello? Okay, it's okay. So let's proceed. Customer. What is the customer name? What is customer country? Country ID. Country name. Region ID. And region name. Now when we say attributes, attributes are something which gives more details about an entity. Entity is a subject area. Now when I say customer 001, his name is Raju. Raju is from US. The name is the full form of US, United States. His region is PA. He is from Pennsylvania. So what are the attributes in this example? Country is an attribute to the customer because it gives more details about customer. Region is an attribute to the customer because it tells where this customer is from. He's from Pennsylvania. At the same time, this is of type attributes. Is nothing but which gives more details about an entity. Now what is text then? Now here we would see this is also a text, nothing but descriptive data. And how does description differ from text? Text is multilinguistic in the sense the same United States can be represented in Chinese, can be represented in Japanese or in German. Text is something, the description is represented in multiple languages. It's nothing but multilinguistic. Now what is a hierarchy? Hierarchy which gives more details, hierarchy which is represented in the form of parent and child. For example, let us take year. Year is 2014. In the year 2014, quarter is Q1, month is Jan, week is second week, and day is 8th. So this is a time hierarchy where year is the parent for quarter and quarter for month and month for week and week for day. Hierarchical representation of data. It's a level hierarchy. Now let us take material hierarchy. In a material hierarchy, you have on the top material group. Material group is furniture. Under furniture, what is the material? We have table. Material hierarchy. Data. 3 types. Structured, semi-structured, unstructured. Structured data, master data is a data that does not change frequently. Example, attributes, country, region, which gives more details about an entity. Region gives more details about customer. Raju is from US, he is from Pennsylvania. What is the basic difference between an attribute and a text? Text can be in multiple languages. Hierarchy is represented in parent and child fashion. Time hierarchy. What is transaction data? Transaction data is a data that changes frequently on a daily basis. For example, customers are purchasing products. Customers are purchasing products. What is the gross revenue? What is the gross revenue? What is the gross revenue? Ashwak?
Yeah, hello.
Hi Ashwak.
Good. Hi, how are you?
I'm doing good. Should I make you organizer? You want to record the session? Just try. I'll make you organizer. If you're not able to record, you can just go out of the session and re-log in. I'm recording behalf of you. Okay?
Oh, are you? Okay, okay.
I'm recording behalf of you. You want me to make you?
I don't have option to record though.
No, I'll make you organizer. But just check if you can record. You record. Otherwise, you can. If you can't hear me, you can log out and log in again.
Okay.
Okay. I'm making organizer. Can you hear Ashwak? Ashwak, are you there?
Yeah.
Oh, you can hear me. Okay. Then you can record your own session.
Yes, I can hear. Yeah, okay, fine.
You can record your own session, yeah. We just started, Ashwak. We just started to discuss about what is master data and transaction data.
All right.
Sorry?
Yes, okay.
Continue the session. Please go to mute, please. Transaction data is a data that changes frequently. For example, what is the gross revenue? Revenue is amount related data. Amount is associated with currencies, like whether the amount is in INR, GBP or USD. Actual ordered quantity. What is the actual ordered quantity or invoiced quantity? Nothing but quantity related data, always associated with unit of measures, like whether it is 1 kg of gold or 1 gram of, it's 1 liter, 1 ounce. So transaction data is a data that changes frequently, and most of the time amount and quantity related data. Amount associated with currencies and quantity associated with unit of measure. Now what is semi-structured data? Now does HANA process semi-structured data? Yes. Semi-structured data is a data, it's simply in the form of text, like text in the newspaper or a text in a Word document or a PDF document. Or you want to analyze sentiment analysis, you want to do a sentiment analysis on a particular product. For example, a new product is released into market, and then you would like to know based on the geographical location, what are the reviews of that particular product in the market? How many people are saying good? How many people are saying bad? The data is not in the form of table, but it is a form of text. You can do text analysis. Nothing but semi-structured data. HANA can process semi-structured data. Unstructured data. HANA cannot process unstructured data. Unstructured data in the sense data in the form of photos or videos. I'll tell you a small example. Let us say there is a severe accident on the NH9, and then a person over there, he taken a photograph of that particular accident location, and then he uploaded that photo to the server. So once the photo is uploaded to the server, there are other millions of photos that have already accident taken place. The newly uploaded photo will compare to the millions of those photos, and it gives the impact analysis. Based on the report on that photo, it sends the report to the hospital location, the nearby hospital, and then the hospital will send the required equipment, like how many ambulances are needed, how many doctors are needed, what is the kind of equipment that is necessary at the accident location. But previously, when an accident happened, there was no much visibility and what is the kind of equipment need to send, and it used to take a lot of time. So now we can also process unstructured data, but outside HANA, which is called, we can process in something called Hadoop. Hadoop has a capability of processing unstructured data, and this data is accessed by HANA using something called Smart Data Access. So at the HANA Studio, you have data provisioning, which is Smart Data Access. You can access Hadoop sources. So using Smart Data Access, you can access the data from Hadoop. But inbuilt in HANA, we do not have capability of processing unstructured data. HANA can process structured data in the form of tables and data in the form of text. In order to process unstructured data, it uses Smart Data Access to integrate with Hadoop. This is brief introduction about data. Coming to the next word, what is modeling? Let us come to the next word, modeling. Defining a relationship between tables in a very simple term. There are two kinds of modeling. One is called entity relationship modeling. The other one is called as multi-dimension modeling. Now, what is the basic difference between ERM modeling and MDM modeling Does HANA support both of them? ERM modeling is optimized for OLTP, and MDM modeling is optimized for OLAP. Online transaction processing, online analytical processing. HANA is a in-memory DB, column-oriented, parallel processing. It does OLTP as well as OLAP modeling. Online transaction processing systems are optimized for writing of data, whereas OLAP systems are optimized for reads of data. These systems are generally normalized and these are denormalized. For example, let us take, usually in a business process, if you take sales and distribution. I am telling a simple example for normalization and denormalization. Customer has placed some orders. So you're writing orders in a table called orders table, and the orders are delivered to the customer. So what orders have been delivered in a different table and what orders have been billed in a different table. So customer has ordered 10 pizzas. 5 pizzas have been delivered and 5 pizzas have been billed. Usually in OLTP, order tables is different, delivery and billing tables are different. We don't write data in a single table. We have joins between these tables. When you want to do reporting, we report on all these 3 tables to get the overall pictures of the overall overview of the sales. In order to answer a question, what are orders, and in these orders what have been delivered and what are open items and what have been not delivered and what orders have been billed to the customers. Someone has joined newly. Hello? Okay, so let's continue. So online transaction processing systems are optimized for writing of data. So when you write data, the respective data goes to the respective tables. So what we try to do, someone is not muted themselves. Kindly please mute yourself. EcuteSoft? Hello? Hello, EcuteSoft? Hello? Please mute yourself, there's a little disturbance. Hello? Hello? Online transaction processing systems are optimized for writes. Whenever you create sales orders, delivery documents, billing documents. For example, let us take an example in SAP itself. In SAP, the order related data is created in VBAK. The delivery related data is created at VBDB. UK, and bill related data is done at VB RK. These are standard tables in SAP. But when you come to OLAP modeling, all these three tables are three transaction tables. When you do the ETL process, we make them to converge into a one single table, which is called as fact table. Fact tables are usually very large tables. They contain lot of data. They contain transaction data. Hello, Sagar.
Yeah. Yes.
You have joined just now?
Yeah, actually, I'm pretty confused. They gave me a different link. I was waiting there for half an hour,
Okay.
and I was like, I told them, like, this is not acceptable.
Okay,
I
Sagar.
was waiting there for half an hour, and they told me there is no class.
Sagar, probably there is some miscommunication. Don't worry. You can use the same link from the next time. Yeah.
Okay.
Okay. We are all the participants are there in the class. We just started with the session. Don't worry, Sagar. We'll talk offline. Probably you are using the old link to log in. Sagar, I'll make you organizer so you can record your session. Sagar, are you able to hear me? Hello, Sagar. Sagar, are you there?
Yeah, yeah.
Okay, please record your session. Okay. So from next time, we all will use the same link for the next all the sessions. Yeah. For the next month, 1 month, for all the weekend session, we would use the same link.
Yeah, excuse me, Nagarjuna.
Yes, please. Who is this? May I know your name?
Hello. Yeah, yeah, this is Ashraf again.
Hi, Ashraf.
Yeah, you said earlier that you are also recording too, right?
Yeah,
Just in case if nobody has recorded their session, they can get it from you.
yeah,
From
exactly.
your.
I can send you that session. Don't worry about it. Yeah. So I'll send you to your email. I'll send you. Even Sagar, I'll send you the session. Don't worry. Yeah.
Thank you.
So now in SAP, we usually write data in different smaller tables rather than writing in one large table. Especially for transaction processing, the data should be small at the table for faster inserts and updates of data. But when you read, when you do set processing of data, we read only few columns but all the data. Fact table has the entire data of all these three tables, and this table is called as, let us keep a name called sales overview table. So all the orders, delivery, billing is on, so this is denormalized. You have redundant data. In ERM modeling, usually you have complex joins between tables. But in MDM modeling, the schema is based on star schema. Where fact table in the center is surrounded by dimension tables. Where fact has lot of data, transaction data. And in the dimension tables, you usually store master data. Master data is the data that doesn't change frequently. the fact you have amount and quantity related data. Master data for customer, master data for material. So each dimension is a subject area. Time, sales arc, and the schema is represented in the form of star. It's called a star schema. And these schemas are optimized for multi-dimensional reporting. You can ask different questions like, who are my top customers? A dimension is nothing but it's a perspective in which you want to analyze the facts. Now let us say we have a fact called net revenue. I have a fact called net revenue. So I want to understand who are my top customers based on net revenue. Customer is a perspective in which you want to analyze net revenue. Now on a different perspective, you want to ask in a different question, what are my top materials, or materials, top bottom materials. You want to do a comparison for net revenue for last 5 years. What is my net revenue based on last 5 years? You can ask any question, you can ask broader question, you can ask deeper question, any kind of question, a multi-dimensional question. I can tell you a question, what customers are purchasing what materials, and these materials are bought in what time, and they belong to what sales organization. The question that I asked now is based on different dimensions. So HANA can support both OLTP, online transaction processing, as well as online analytical processing style of queries. So in the first slide, we are trying to understand master data and transaction data. The second one, we are trying to see the master data is stored in a dimension and transaction data is stored in the fact tables. OLTP systems are optimized for writes, whereas OLAP, online analytical processing, are optimized for reads of data. How fast HANA can read? It can read 3.2 billion records per second per core and 15 million aggregations per second per core. That is the fast that the OLAP.
Muted. Unmuted.
Please kindly don't mute me. Someone is trying to mute me. Please don't mute me.
Yeah, I missed that. You just said what? I think you got muted for a few seconds. Can you repeat that here?
Yeah. HANA can support both OLTP, online transaction processing, as well as can support online analytical processing. It does 3.2 billion records per second per core, the scan speed, and 15 million aggregations per second per core. So that is the speed of HANA for each core. For each CPU, HANA scans 3.2 and aggregates 15 million aggregations per second per core. It's per second. Now we are trying to understand what is data and what is modeling and data modeling. Nothing but defining a relationship between tables, and these tables are designed in such a way that either you can create complex joins between tables, and these are called as entity relationship models, or you can design schema in such a way it's a multi-dimensional model where you have fact table in the center surrounded by dimension tables. So these are very general concepts when we talk about any data warehousing solution. Now let us move on to HANA technically. Let us see the technical aspect in HANA.
Nagarjuna, Mahendra here.
Yes, Mahendra.
Hello.
Yes, Mahendra, please go ahead.
Just one more doubt. We can see the terminology like facts and measures.
Yeah.
The facts are nothing but attributes which we had discussed, right? Is it the same thing, or attributes and test?
Facts are nothing but transaction data. They are measures, Mahendra. Here, facts are nothing but like gross revenue. These are facts, nothing but measures. But where attributes are customer, material, master data.
Oh, that means you means fact and measures both are same.
Correct, Mahendra.
Okay.
Facts are nothing but measures.
Okay.
Attributes are nothing but master data.
Okay.
Nagarjun, Sandeep here. I have a quick question regarding the relationship in between cores, blades, and the CPU. As just a while back you were explaining about the processing and scanning power of each CPU, right?
Yeah.
Yeah, just would like to know the link in between the cores, blades, and how many cores consist of a CPU.
It is not fixed. It is case to case. For example, when you have only one, it is called one CPU. And if the CPUs are inside CPUs, then it is called core. So when we say quad core, it consists of 4 CPUs, but it is nothing but, again it's a CPU, but usually these are called cores.
How about the blades?
Blade is different terminology. Every company uses their own terminology. IBM uses blade. Other companies uses racks. Rack server, blade servers. So each company has their own terminology. A rack is nothing but it's a motherboard. In one motherboard you can have CPUs. Inside CPUs you have cores. They're called cores. Outside is CPU, and this is on one motherboard. So 2 CPUs you have on this motherboard. If each CPU consists of 4 cores, then totally on this particular rack you have 8 core CPU.
Okay,
Alright?
thank you.
Alright? Yeah, welcome. So let us go to the HANA data modeling. So let me show you how to log on to HANA Studio. Click Start. Click HANA Studio. For the first time, when you log on to the HANA Studio, you get something called a welcome message. It would be something like this for the first time. You know, right? Each one of you will get a 3 months server access. So you'll be provided for 3 months server access from the start date of your access. So for the first time when you log on to the HANA Studio, you get this welcome page. So once you close this welcome page for the first time, then here you see systems. Right click on this free space and click add system. Give the host name HANA server, instance 07, description SAP HANA. Click next. We all share the same user ID and password. So whatever I am doing in this exercise, we all share the same user ID and password so that we don't have any discrepancy when doing practical. Give the user HANA user and password is W capital welcome 1234. In welcome 1234, you need to type in W as the capital letter. Store username and password and finish. So now the system is added to the HANA Studio. Once you add this, one minute. Excuse me. So once you give the system, so here first one is catalog. Content. Data modeling. So once you add instance or once you add system, at the HANA you basically see two folders. One is called catalog, the other one is called content. Catalog is a collection of schema. Go to HANA Studio. If you expand catalog, under catalog you have schemas. I'll just use my backup server. So let's continue. So catalog. Catalog is a collection of schema, and schema is a collection of database objects like tables. Go to the HANA Studio. Here you have two folders. One is catalog, the other one is content. Expand catalog, and here you see different schema. Database objects are grouped under schema. Database objects like tables. For example, I have a user called HANA user. So we have a work area for HANA user. This is schema. Expand schema. Here you would have tables, and here you have row oriented as well as columnar tables. So let us find for a table KNA1. So here you find the table KNA1. Right click on the table, open content. So what I'm trying to say over here is so tables are grouped under schema and schemas are grouped under catalog. Content. Content is a collection of packages. Content is a collection of packages. Packages have information views. information is nothing but processed data. View doesn't hold any data. It accesses data in the runtime. So views access data from tables and tables schema and schema under catalog. So these views access data from tables. These tables, you have different kinds of tables or different types of tables that store business data. Tables that store master data like attributes, tables that store text data like text tables, tables that store transaction data, transaction tables. Views access data runtime from tables, and these tables are columnar tables or column oriented tables. So if you see my first session, we discussed about column table is divided into two parts. One is main area. Every table, a column table, is divided into two parts, and the other one is delta. Whenever we insert data, the data first goes to the delta area. First, the data goes to the delta storage, and then it executes a job, other words called delta merge. The data is moved from delta area to the main area. It does dictionary compression, nothing but encoding of data. Encoding is nothing but converting from strings to integers, so it takes less space on memory. When it takes less space on memory, it can load faster to the CPU. If it loads faster to the CPU, user can access data faster. So all these things we have discussed in the first class. So now what I am trying to focus now, all these tables are columnar tables, and these tables are grouped under schema. And these tables are, some tables store attribute data, they call attribute tables. Text tables store text data, and transaction tables store transaction data. Content. Content is a collection of package. Now what is a package? Packages are used to group together related information. For example, I have a package called sales. I have other package called HR. And FI. Sales and distribution. Under sales and distribution, you can have sub packages. You're trying to group information views. Like you can have order related data, delivery related, and billing related. You can group information views. Under HR, you can have personal administration, compensation management, succession planning, e-recruitment, all belong to HR. Payroll, time management. FI, general ledger, account receivables, account payables. So packages are used to group together related information. So all information views that are relevant for sales are grouped under package. All objects relevant to HR are grouped under HR package. And these information views are grouped according to the application. So first, let us start creating a package. Go to the HANA Studio. So we already have the relevant tables. Right click on the content, new, package, give the name for the package. SAP SD weekend batch. Click OK. Usually in real working environment, we don't create objects directly in the main package. We have something called dummy package. First we create in dummy package so all the objects are first created in the dummy package. Suppose say you created 10 objects. You're just trying to test, modify, keep testing objects. Out of these 10 objects you have finalized 2 objects, and only these 2 objects you move to the main package. For example, in our project we are 10 developers. Each developer will work on his local package or a dummy package. When all the developers finishes their work, now before the UAT, when you want to transport objects from a development to QA, during this time we try to group all the relevant views in the respective packages. These we do something called refactoring. So when you right click on any view, just I'm showing you an example. Right click on any view, there's something called refactor, move. You can move objects from dummy package to the main package. We don't move all the views to the quality or to the quality system. Only the finalized objects will be moved, but each developer first can work on dummy package and then can move on to the main package.
Nagarjuna, one question here.
Yes, please.
Sorry.
Yes, please.
Yeah, Nagarjuna Mahendra here. While we moving the package views from dummy package to main package, is there any kind of complete copy or kind of delta link? That means, is there any reference will be maintained continuously?
No, Mahendra, there will not be any reference. Once
Okay.
you move,
That means whenever we have done any changes in the dummy package, again we need to copy it again, right?
now, for example, you move to the main package and then you transport it to the quality.
Okay.
The quality user has tested and told to make some changes.
Yeah.
And then again you come back to the main package,
Okay.
because that's a finalized object now. And
Okay, that means we can directly do the changes in the main package.
exactly.
Okay.
Yeah. So let us assume for some time that this is a dummy package we are working on, and later we create a main package and move these objects from this dummy package to the main package. So that's why I named it as ASD weekend batch. Okay. Package. So whenever you see something called distorted in HANA, whenever you think something is what you want to see is not visible, then simply you can come to the default perspective. Click Windows, click Reset Perspective. So once you click Reset Perspective, it will come to the original perspective. And click HANA Administration Console, and once more click HANA Modeler. Now here you would see Quick Launch. So in the Quick Launch you see various options like New, Content, Data, Setup. So first let us start with New. Package are used to group together related information objects for structuring purpose. Under this package you have information views. Information views are of three types. One is attribute view, the second one analytic view, third one calculation view. Let us first start with attribute view. What is an attribute view and when do we use attribute view? In order to demonstrate further on this, I would like to take a scenario. Based on that scenario, we do data modeling. So let us say the customer has given a requirement. The requirement is something like this. Now during the workshop we gathered the requirement, and based on the requirement we want to build a technical specification. So let us take the requirement from the customer. Excuse me. Now customer wants to develop a report based on this information. He wants to develop a report in HANA. The report that we are developing now is for an application called in SAP, it's called as SAP COPA, Controlling Profitability Analysis. We'll discuss this term detailedly, but before that, let us try to understand what is the requirement, and based on the requirement, how we have to create data modeling at the HANA system. So first we require where is the customer ID in SAP? It's in the table KNA1. KNA1 is a table for customer attribute data. Name is also in KNA1. Country ID is in the table KNA1. Country text is in table T005T. Region is in the table KNA1. And region text is in the T005U. We'll see this. Just I'm trying to, and the column here is known as KUNNR, name 1, land 1, land X, regio, BE, JDI. Table material MARA, MATNR, material text MAKT, column MAKTX. Metal group MARA, the column name is MATKL. Gross revenue, transaction data, table CE1 IDEA, column VV010, sales reduction CE1 IDEA, BV070, and net revenue is, it's a formula, VV010 minus VV070. Now whenever the entities are given in the functional specification, so based on the functional specification, we need to identify where this data is located in the standard tables. That is the first thing that we have to do as a part of the technical spec. So we need to identify where these tables are and what columns in the tables. This is for customer master. The second one for material, and the third one for transaction data. So first let us focus on customer master data. So let me log on to the ECC. So before we start doing data modeling, we need to have all this information ready to start the data modeling. So let's go to the ECC. Go to SAP logon. Double click on ECC. give the username and password. Click OK. Enter the transaction code SE11. SE11 is a transaction code to view tables. SE11, enter. Now let us give the table name KNA1. This is a standard table from SAP. Click display. And now please select the columns that I require for my reporting. KUNNR, land 1, regio, name 1. So customer, let me save the file. So here, so if you see the requirement, first is customer ID. The customer ID is in the table KNA1. KUNNR is a column. Name, name 1. Country ID, land 1. So please see, we do not have LandX in this table. It's in a different table, T005T. So we'll see later. Now the other column in the KNA1 is the regio. So totally we have 4 columns from this table. So let us go to the other column, T005T. Create session. Give the transaction code SE11. Enter. And give the table name T005T. Click display. Now here we find LandX, which is nothing but text data. So LandX is nothing but T005T is a text table for country. And let me open other session. Create session. Give the table T005U, S11, T005U. Click display. All these are standard tables from SAP. So the text column is BJDI. Is nothing but it's a description column. So once you identify tables, now suppose say we do not know, it is not necessary that we know all the tables, because in SAP itself you have more than 1 million tables. What if we do not know the tables and the columns in the table? We have to find out. So we would take the help of ABAP guy in the project, or you can also contact functional people, because you're working on the HANA side and we may work on any functional area. You may work on HR, you may work on FI, you may work on SD, or you may also work on industry specific solutions. We know HANA very well. We know the technical aspect of HANA, how to do data modeling, but probably we may not have idea about the functional, because every project is different in nature. Every business has a different kind of business. They have a different specific business flow. So always this technical spec is only achieved through teamwork. Probably if you're already if you have knowledge, you may work on that particular area, but if you do not have, you can search Google, or you can ask ABAPer, you can ask functional guy, or even you can ask the end user. For example, you can ask them where they were referring to this column in previous screen. Usually you can take help of F1. For example, there are small tips and tricks to find out these tables and columns in SAP. So finally, ultimately we have to get this done before we start any data modeling. So once this is done, the next step is we need to come up with the data model. In the sense, how your model should look. You need to have detailed design documents and high-level design documents. So let us now convert this technical spec into a data model diagram. Now here we see customer is one entity and the material is another entity, and you have transaction data. Now how do we do data modeling out of this technical spec? So let us create a star schema. So in the first, once the technical spec is available, so you have a dimension. This is a customer dimension. It's a subject area. And this one is the material dimension. This is time. And this is company code. And let us, now what should be the columns in this dimension? Like you need to have KUNNR. You need to basically come up with this diagram. Name 1, Regio, BZDI, Land 1, Landex. In the material, MATNR, MAKTX, MATKL. In time, year. It's very easy. Just I'll try to, let us try to understand. Quarter, month, the company code I want. we need to come up with a data model diagram. Now once you come up with a data model diagram, then you can start building the object. Now you need to list down from this what we need to start creating. So we need to create one customer dimension, you need to create material dimension, you need to create time, and you need to create company code. And the transaction data that you need is this one. Okay, now coming back to our original topic. So once you get the requirement, based on the requirement, we need to convert them into high-level design document, come up with a data model diagram, and once you come up with the data model diagram, then you need to identify the objects that you need to start creating. So let's come back to the HANA Studio, and then we already have package. Like we created a package called SAP SD. SAP SD weekend batch. Now let us try to understand what is an attribute view. Now in an attribute view, what is an attribute? Gives more details about an entity. When it's an attribute, simply we can say it's a master data. Let us try to understand the definition. I'll come back to the technical spec, but before that let us try to understand this. Attribute views are reusable dimensions or subject areas used for business analysis. You can also use attribute views to join master data tables to each other. Now there are two important words over here. One is So simple definition of an attribute view is it's a reusable dimension used to join master data tables. That's it. It's very simple to remember. Attribute views are reusable dimension join master data tables. So first of all, what is reusable? Reusable is nothing but shared. You can share. You can share attribute views. Now what is a dimension? The perspective in which you want to view data, or the angle in which you want to view data. Now what is join master data table? You can join tables unless and until you join we join. To achieve this subject area for customer, we have three tables. KNA1 is one table, T005T is the other table, and T005U is the other table. Unless and until we join all these three tables, we cannot achieve customer dimension. We cannot get this output. So the customer dimension consists of master data. Master data is a data that does not change frequently. The customer data does not change frequently. For example, the customer ID of bank, account number, his postcode, address, all these are at the dimension. And this customer information can be reusable. You can reuse to a different transaction data. So a dimension is the perspective in which you want to analyze the transaction data. Now this is what I'm talking about. Reusable dimension and join master data is what? This one is nothing but an attribute view. It's an attribute view for customer. This one is the attribute view for material. So based on the design, now we can simply say what are the attribute views over here, because each one is a subject area. It's a subject areas used for business analysis. You can use this subject area for business analysis, like top customers, top materials. So in here we need to create 4 attribute views. One is for customer, the other one for material, the third one for time, and fourth one for company code. So we need to create 4 attribute views. Attribute views are nothing but reusable dimensions used to join master data tables. So let us first start. Let us first start with creating attribute view for customer. So let us take this requirement and start building the attribute view. Now let us come up with a detailed design document. This is a high level, like a data model, but how these attribute views should be built and what could be the relationship between these tables. That is what the next step is. First, based on the functional spec, we try to identify what tables are used, what fields are used, and based on that I come up with the data model diagram, and based on the data model diagram, in order to develop a particular attribute view called customer, sorry, I have written here customer, I'm sorry, I have to give in material. In order to develop a model for customer, let us do a detail level document. In order to achieve the requirement for the data model, in order to achieve this data model, how do we achieve this? So when you create an attribute view, now as you know, inside this attribute view we have 3 tables. One is KNA1, the other one is T005T, the third one is T005U. KNA1 table. So what columns we have? KUNNR, name 1, land 1, regio, land 1, land X, and you have a language column which is called SRAS in T005U. We have land 1, regio, B land, and B JDI. This is for AT underscore customer. This is nothing but the attribute view. So first is identification of tables, and the second step is, now we need to know, the first step is identify the respective tables. The second step is create joins between tables. The third step is output columns, field selection for output. The fourth step is define a key attribute, and final step is validate and save and activate. Technically, we need to build the solution like this, build the attribute view like this. The first is identify tables, we have done. The second is create joins between tables. A join is a relation between table. You join land 1 to land 1, join land 1 to land 1. I'll tell you why we need to do like this. Join regio to B land. The output of this is nothing but the output of this field selection for output is nothing but this is the output we get finally. Now let us have some dummy data. For example, the customer is 001. Same, his name is Raju. He is from US, United States. He is from region PA, Pennsylvania. So now I come back to bottom. So when I say land 1 is US, so land 1 US is equal to US inner join. It's an inner join. Inner join is nothing but it's a common area between both the tables. Common values between land 1 and land 1 of T005T. So if you have US over here, you'd also have US over here, and the text is United States. if region is PA, and if US is US, if B land is PA, then the text would be Pennsylvania. So let us first check data whether the relationship is correct or not. So let us see whether the relationship is correct or not. Okay, let us start. So let's go on to the ECC. So before that, until here, before I basically start showing the practical on this, if you have any doubts based on this, please go ahead. Before we go any further, if you have any doubts on this slide, please go ahead. Okay, then let's continue the class. So first, let us try to see the data. So let's go to the table and then let us try to see the data first. Now if you go to the KNA1 table, now please see, I've taken a requirement. Based on the requirement, I've taken 4 columns. If you click contents and click execute, here we see the data. If customer is 001, he is from US. His name is Nelson Tax Associates. He is from region PA. But I could not see text for this, which are in green color. In order to know the text for US, it is stored in a different table. Data is normalized. The text is stored in a different table called T005T. If I click contents, now what I need to give here, now please, according to my diagram, if the land one is equal to US and T005T, the land one should be US. Yeah. So let me go to the T005T and then let me type in US. Now once you give US, now it would show in lot of languages because it's a descriptive data. T005T is a text table, so US will have different languages. So one US land one is stored in different languages. Please see. So you almost have 29 languages that are stored, the same US text. But this is not my requirement. I need only English. Because at a particular point of time, a user can either see English or Chinese. Probably he may not see in both the languages. So the language key, which is called SPLAS, which is the language key, I would take it as English. And now I see only one line would be displayed. That is US means United States. I hope now we got the relationship between KNU1 table and T005T. What is missing in the KNU1 is the text, because as per the user requirement, the user has asked us to display United States, but we do not have United States in the KNU1 table, so we need to join with T005T to get the text for US. The same follows with the regio. T005U is a region table. Click display, click contents. Now if I only specify US and the B land, in US what is the region? PA, nothing but the text is stored in here, which is BEJDI. If I don't specify language, again it shows Pennsylvania in different text. In Chinese, but I would like to only see in English. So specify EN and execute. So now my requirement is fulfilled. From T005T I would get text for country, and T005U I would get text for region. So let us start data modeling for customer. So first this done, identification of tables. So we start creation of attribute view. Attribute views are reusable dimensions, subject areas used for business analysis. You can use attribute views to join master data tables. So all these are master tables. Master data, text, attributes, hierarchy. You can join these tables inside the attribute view, and this attribute view is called as a dimension. A dimension is nothing but the perspective in which you want to analyze the data in a star schema. So in a star schema, the dimension is nothing but the attribute view, and it is reusable, or it can be shared. It can be shareable. Right click on the package, new, click attribute view. Attribute view is an information view. These are information views. Always start the attribute view technical name, best practice. With 80 underscore customer view subtype is standard, but you have three types of attribute views. Subtypes: standard, time, and derived. So first let us start with standard, then on the coming classes we would see time and derived. So let us just start with standard for now. Click finish. So once you finish, here you would see scenario pane, data foundation, semantics. Now what is data foundation and what is semantics? This is nothing but the data foundation. A data foundation is a place where we define a relationship between tables. So what tables we require in order to create this data foundation? Three tables: KNA1, 5T, and 5U. Click the plus icon, add objects, or select the data foundation. You can also add over here, or alternatively you can drag and drop tables from the catalog. So three ways you can actually add tables to the data foundation. So HANA user is a schema, expand tables, expand schema, expand tables. The table name is KNA1. The table name is T005T. Table name is T005U. We have all the three tables. So I'll show you the three ways how to add tables at the data foundation. Click add objects, T005T, HANA user. You can add like this. the other table, let us drag and drop from the schema. KNA1, drag and drop like this. So now whenever you add the data foundation, you see tables at the details pane, and here is the output pane, and here is the properties pane. So you can also add like this, add T005U. Click OK. So now we have all the required tables as per the requirement. So this was the requirement from the end user. So based on this requirement, we have designed the data model. We selected the required tables in the data foundation, and then we need to start creating joins between these tables. I'm just trying to arrange the tables. Now already we know the relationship between KNA1. If land is equal to US, then TC, I'm trying to join. You can either join like this, or if you want to delete, right click, select and delete or remove. Or if you want to create a join, right click on land 1, create join. Alternatively, you can do like this. So both the ways, either you can join like this, or right click on the table, create join. Click create join. Always make sure that the text table is on the right hand side. Why? Because we need to specify the language column. If you do not specify the language column, what could be the issue? Please see. Now here I specified the language column. If I don't specify SPRAS, then see the number of entries, 29 entries I would get. Now this would lead to a wrong result, because I may not need all the languages. I need only one language, because English user understand English, Chinese user understand Chinese. Always we need to filter on the language column. So land 1 of KNA1 T005T land 1 US is equal to US. That's the inner join. But if we would do inner join, then it would create problem. I mean, it would give wrong result, because it would give us 31 entries. So SAP has a special type of join called text join. So this is the join we need to select in order to give the right result. What is a text join? Based on the user's session, it dynamically restricts the language and only provide the description in that language. So if user is logged in English, the description would be English. If the user log in Chinese, the description would be Chinese. But how would I know what user has logged in? I'll just show you shortly. But before that, let us select text join, and the language column would be Spras, and click OK. So if you want to see what is the user session, right click on the instance, properties, additional properties, the language is English. So the output of the text would be shown in English. So let us first see. You'll understand, and we'll see the output for this, and then we'll have more clarity on this. Join LAN 1 to the LAN 1 and join LAN 1 to LAN 1. And I'm showing the second type how to do the join. The first one I right click and create a join. The second one I drag and drop. So once you join, select join type as text join. You could do like this as well. In the language column, select the join. Language column, we would also take it as Spras. So first is identify tables. Second step, create joins between the tables. The third is, based on the requirement, do the field selection for output. So what's our requirement? From the requirement, what we require? KUNNR. So from KNA1 we require KUNNR. From KNA1 we require KUNNR. Now please see, these are coming to the output columns. Nothing is here. So select KNA1 KUNNR. Output column has come. Name 1 Raju. LAN 1 US. LANDEX from T005T Regio from KNA1 and BJDI from T005U. But we also have to join between Regio and BLAND, because under US you have region Pennsylvania, so PA is equal to PA, the description would be Pennsylvania, and automatically this would take as a text join. You see, automatically it takes as a text join, because if one join is a text join, the other would also be a text join for the same table. Now based on our requirement, we have selected customer name, what is his country, and what is his region. So we've done the third step, field selection for output. The output of the attribute view is at the semantics. So this is the output. We need to have at least one key attribute for KUNNR. Let us select one key attribute. Now what is the primary purpose of key attribute? Key attribute is a primary key in the dimension table, and it would have the same foreign key. It would have the same foreign key in the fact table. Select this as key attribute. If you don't select key attribute, then it would throw an error saying that we need to have at least one key attribute in the attribute view. So once this is done, next is we do something called label mapping or descriptive mapping. Key and text functionality. If 001 is Raju, if US is United States and PA is Pennsylvania, why do we have to have two columns? We would map with the same column. So KUNNR 001 is Raju and US is United States and Regio is Pennsylvania. See, PA Pennsylvania, US United States, and 001 is Raju. And hide the text columns because key and text, key KUNNR and text is Raju. And then click save and validate and save and activate. Once the view is activated, then in order to display data for the view, expand content, go to SAP SD Weekend Batch, package, expand attribute views, and here you see with three triangles a blue color icon. Right click on this, data preview. Once you click data preview, click raw data, and here you would see (001) is customer, US is United States, and PA is Pennsylvania. Please see, by combining all these three tables, I was able to fulfill the customer requirement. So this is the customer requirement and by creating an attribute view I fulfill this requirement. Now again we finished a part of this, we need to do other parts as well. So I drew a detailed design document, and based on this is the output. In order to verify this output, you can just go to the source and see the data, whether we are doing correct or not. You can do unit testing. 001 Nelson Tax Associates, US means United States and PM means Pennsylvania. But how about testing a text join? So let us test the text join. Right click on the instance, click properties, and then click additional properties and locally select as Chinese. Now we should be able to see the text displayed is Chinese because the user session is Chinese. Click apply. And click OK. Now once we have done, let us go to SAP SD. And let us data preview once again. Right click and data preview. And this time the text should be shown as Chinese. And that's the functionality of the text join. If you want to verify, we can verify from here. From T005 view, we taken as English, but let us take Chinese. ZH, Chinese for region. And for T005 view, 5T, display contents, language is English, language is Chinese, US, execute, land axis. Let's verify the result. So I'll stop for today. If you have any doubts on the attribute view, please go ahead. Tomorrow we meet at the same time, 6 o'clock. For today, if you have any doubts, please go ahead. For your user access, please drop me an email to my ID and I think you know my contact number 77 999 111 29. For any issues, contact this number.
Nagarjun.
Mr. Nagarjun, I have a
so
question to ask you.
Also, please send a request for material. I would send you the material, and also make sure that you 100% complete the certification. For people who want to attend the certification. Yes, please. Any doubt you have? Someone is asking some question.
Nagarjun, Sandeep here. So basically this analytical...
Attribute view.
Hello?
Yes, please, Sandeep.
Yeah. So basically this can be considered as a dimension linked to the fact table to form a star schema, right?
Perfect.
So can we link multiple analytic views, so that it could be like a snowflake schema?
Yes, you can do that, but that should be done in a calculation view.
Sorry, in the calculation view.
The third one.
Yeah, I'm talking about the calculation view only.
Yeah, you can do that, Sandeep.
So basically then HANA data modeling could be done on star schema and as well as snowflake schema based on the requirement.
Exactly.
Alright.
But we would see about that in future classes. Today we are only dealing about basic class. So we'll go step by step, yeah? Any more questions? Please go ahead.
Mr. Nagar, are you going to send us the recording for the first class?
Yes. Yes, please. Just drop me an email. Please drop me an email if you have any recording missing. Please drop an email. I would send you.
The strange thing is, Mr. Nagar, that I tried to record your last week one, but it didn't show up, which means I have some issue with the recording. So I doubt that even today's class, I don't know whether we can get it the recording or not. Is there any way we can get all like all the recordings from you?
No, we can do that. No problem. Don't worry about recording. I always do recording. You can get the recording. Just drop me an email. Yeah, Zubair?
For sure, for sure. Thank you very much.
So tomorrow, again we meet at same time at 6 o'clock.
Thanks, Nagarjun.
Thank you.